You know, one of the best things about Python is how simple and intuitive it feels. But what if I told you that its effortless vibe isn't an accident? What if it's all guided by a kind of hidden script? Let's pull back that curtain.
Think about your favorite podcasts. The best ones feel like you're just listening in on a super interesting, natural conversation. It feels totally off the cuff, like magic, right?
Well, here's the secret. That spontaneous magic is almost always the result of a ton of work behind the scenes. There's a script, an outline, a plan, all designed to make it feel effortless.
And that, right there, is the perfect analogy for Python. The reason it's so easy to read and write isn't by chance. It's the result of a very deliberate, very clever script running under the hood.
So let's start there. Let's talk about this illusion of simplicity. Because Python's famous readability, it's not a bug, it's a very carefully crafted feature.
So one of the first things you learn about Python is that it's dynamically typed. You don't have to declare that a variable is a number or a string. You can just say x equals 10, and then on the very next line say x equals hello. Python just figures it out.
And that feels just like our podcast conversation, doesn't it? It feels spontaneous. But what's really happening is that Python is acting like a brilliant producer, making all these complex decisions about data types for you, so you can focus on the bigger picture. Okay, so if Python is directing the show, we have to talk about pacing. And in the world of code, pacing has a name: time complexity. It's absolutely crucial for understanding how your code actually performs.
So what in the world is time complexity? Well, simply put, it's just a way of asking, as I give my code more stuff to do, how much longer is it going to take?
Let's go back to our podcast analogy. An operation with O1 complexity, you'll hear it called big O of 1, is like your podcast's intro music. It's the same length every single time. But an O of N operation? That's your main discussion. The more topics you add, the longer it gets. The runtime grows along with your input.
Now let's see this in action. Look at this table. If you have a list, kind of like a long ordered script, and you want to see if an item is in it, Python might have to check every single line from top to bottom. That's ON. But if you use a set, which is more like a checklist of topics, it can tell you almost instantly. That's O1. A huge difference.
And that's the whole point. Choosing the right data structure isn't just some academic exercise. It's like deciding if you need a detailed word-for-word script or just a few bullet points. Making the right choice has a massive impact on your code's performance.
All right, let's build on that. The next big idea is about changing things, or not changing things. Think of it as the difference between a live, editable draft and a final, locked-in copy.
See, in Python, you've got two basic kinds of objects. Mutable objects, like lists, can be changed after you create them. But immutable objects, like strings or tuples, are set in stone. If you want to change one, Python has to secretly make a whole new object. Now, this is where it can get a little wild, so stick with me. Let's say you make a list and call it A. Then you say B equals A. Now, you'd think you have two separate lists, right? Well, you don't.
So what happens if we go and change an item in that list, but we do it using the variable A?
And here's the twist, because A and B are just two different names pointing at the exact same list. When you look at B, the change is there too. And trust me, this can cause some of the most confusing bugs you will ever encounter.
This diagram shows you exactly what's happening. The variables A and B aren't holding the list. They're just like two sticky notes pointing to the same box in the computer's memory. Change the box's contents, and both notes still point to that changed box.
Okay, so now let's see what happens with an immutable object, like a tuple. If we do the same thing, and then try to change the tuple through A, Python hits a wall. It can't change the original. So instead, it's forced to make a brand new tuple and make A point to that one instead.
And what about poor old B? It's completely unaffected. It's still pointing right at that original, unchanged tuple. And this is a game changer. It makes your code so much safer and more predictable because you never have to worry about something changing out from under you.
And all of this, it leads us to the grand finale, the actual philosophy behind Python's design, because it all boils down to one fundamental trade-off.
I bet a question is popping into your head right now. If Python has to create brand new objects all the time for immutable types, isn't that, really inefficient and slow for the computer?
And the answer to that question gets to the very soul of Python. It's this idea, right here. This is why Python is the way it is. See, Python makes a very conscious trade. It's willing to sacrifice a little bit of machine performance to gain a massive amount of programmer performance. Things like dynamic typing and the safety of immutable objects, they save us, the humans, an incredible amount of time and prevent a ton of headaches.
So this hidden script running behind Python's simplicity leaves us with one last thing to think about. In this constant balancing act of creating things, what's really more valuable? The raw speed of the computer, or the clarity and sanity of the human being who has to write and maintain the code?